Globally, millions of tons of fruits and vegetables are harvested annually. Modern technology is revolutionizing harvesting practices in agriculture. Robots are increasingly being deployed for automated harvesting tasks. Artificial intelligence, AI, enhances precision and efficiency in harvesting operations. Advanced machinery further optimizes harvesting methods in farms and greenhouses. Traditional fruit picking depended on manual labor, a slow and repetitive process. AI-powered robots are now being used to automate apple harvesting. These robots are equipped with cameras and color sensors to identify ripe apples. The AI system analyzes visual data to determine fruit ripeness and location. Silicone fingers or suction cups are used to gently grip and pick the fruit. This gentle approach minimizes damage to the apples during the picking process. Robotic systems are deployed for harvesting strawberries and other berries. These robots utilize computer vision to identify ripe crops. Independent robotic arms enable precise picking of only the mature fruits. Agrobot's E-Series exemplifies this technology with its 24 robotic arms. This system enhances efficiency and reduces labor in strawberry harvesting. Harvesting delicate vegetables like lettuce requires careful handling to avoid damage. Specialized machines are employed to automate the lettuce harvesting process. These machines use blades to precisely cut the lettuce at the base. Sensors are integrated to identify and select mature lettuce heads for harvesting. Conveyor belts gently lift and transport the harvested lettuce. The machines also clean the produce, removing soil and debris to prevent bruising or breakage. Automated systems are employed to ensure efficient carrot harvesting. These machines lift the carrots from the ground. The carrots are then cleaned by the automated system. This process prepares the carrots for transport without causing damage. The VegBot utilizes machine learning to identify vegetables ready for harvest. It is designed to distinguish between healthy and mature vegetables. The VegBot carefully cuts the selected vegetables from the plant. After cutting, it transports the harvested vegetables into designated bins, showcasing AI precision. Modern banana plantations employ cableway and pulley systems for efficient banana transport. These overhead systems move harvested banana bunches from the field to the pack house. The cableway system significantly reduces labor requirements in the transportation process. This method also saves time, leading to increased overall operational efficiency. Mechanical harvesters are used to efficiently collect grapes from vines. These machines gently shake the grapevines to dislodge ripe grapes. The detached grapes are collected into onboard containers for transport. Mechanical harvesters utilize GPS technology for precise navigation within vineyards. Sensors enable operation in low light and varied weather conditions. This technology enhances harvesting speed and reduces labor requirements. Automated harvesting utilizes robots and machines for crop collection. These systems can operate for up to 20 hours daily. This significantly increases harvesting efficiency compared to manual labor. Extended operational time helps maximize crop yield. Automated harvesting can operate day and night. The increased efficiency addresses potential labor shortages in agriculture. Robotic pickers are designed for gentle and precise fruit harvesting. This precision ensures high fruit quality, meeting market standards. The careful handling minimizes damage to the produce during picking. Reduced damage translates to less waste throughout the supply chain. Maintaining fruit integrity is a key advantage of robotic picking systems. Research is actively being conducted to automate the harvesting of soft fruits. Leafy vegetables are also a focus of this automation research. These types of produce are traditionally challenging to handle with automated systems. Current prototypes are improving and becoming more advanced each year. These advancements are expanding the possibilities within agricultural automation. The goal is to create efficient and reliable harvesting robots for delicate crops. Robots are being designed with flexible grippers to replicate the dexterity of human hands. These grippers are equipped with pressure sensors for precise control. The technology is particularly useful for handling delicate crops without damage. This innovation enables safe and efficient harvesting of fragile produce. Field trials evaluate pressure sensors for robotic harvesting systems. These sensors are integrated into the robotic grippers. The primary function is to measure the force applied to crops. This allows robots to adjust their grip in real time. Precise grip control prevents damage during harvesting. Effective pressure sensing ensures gentle and efficient crop handling. Drones are deployed for aerial monitoring of agricultural fields. This monitoring provides data on crop health and growth patterns. Analysis of drone-captured imagery can predict optimal harvest times. Aerial monitoring enables more informed decision-making in farm management. The use of drones promotes efficient resource allocation and sustainable agricultural practices. Data analysis is used to predict optimal harvest times. This analysis relies on data collected by drones. Predicting harvest times allows farmers to plan operations effectively. Effective planning helps in reducing waste. Farmers can optimize resource allocation based on predictions. Data-driven insights lead to more efficient agricultural practices. Automated harvesting systems are increasingly common in North American orchards. These systems enhance the efficiency of harvesting processes. Automation reduces the dependence on manual labor for harvesting tasks. This shift helps to manage labor costs and availability. Automated systems can operate for extended hours, maximizing harvesting output. The adoption of these technologies improves overall orchard productivity. Robotic harvesting is commonly used in European greenhouses. This technology helps maintain a stable supply of produce year-round. Robots en sur consiste au harvesting standard. The result is a reliable source of high-quality produce. Modern transport systems are utilized in Asian plantations to improve efficiency. Cableways are one example of a modern transport system used in plantations. These systems streamline the harvesting process of plantation crops. The implementation of modern transport reduces the need for manual labor. Reduced labor requirements translate into lower operational costs for plantations. Automated harvesting promotes sustainability by significantly reducing agricultural waste. The precision of automated picking minimizes damage to crops during harvesting. Efficient transport systems integrated with automated harvesting further reduce spoilage. Reduced spoilage translates to a greater percentage of harvested crops reaching the market. This minimizes resource consumption associated with growing crops that ultimately go to waste. Therefore, automated harvesting contributes to a more sustainable and efficient agricultural system. Drones and sensors enable optimized irrigation strategies in agriculture. These technologies facilitate a reduction in overall water consumption. Optimized irrigation contributes to more sustainable agricultural practices. Drones provide aerial imagery for assessing crop health and water needs. Sensors monitorent soil moisture level, ensuring precise water delivery. Automated harvesting is improving the efficiency of global food production. This increased efficiency contributes to a more stable food supply. Automated harvesting also promotes a more sustainable food supply. These advancements help ensure food security for future generations. The future of farming is characterized by the integration of advanced technologies. Robots are expected to play a key role in automating various agricultural tasks. Artificial intelligence, AI, will be used to enhance decision-making processes. Data analytics will optimize all stages of the agricultural process, from planting to harvesting. Automated harvesting offers a solution to the increasing challenge of labor shortages in agriculture. It provides farmers with a consistent and effective substitute for manual labor. This technology ensures harvesting operations continue smoothly, even when human labor is scarce. Automated systems can operate for extended hours, increasing harvesting efficiency. The use of automated harvesting reduces the reliance on a fluctuating and sometimes unreliable labor pool. This leads to more predictable harvesting schedules and overall improved farm management. Automated harvesting increases efficiency and precision in agricultural processes. This leads to higher crop yields compared to traditional harvesting methods. Increased yields directly translate to higher incomes for farmers. Automated harvesting contributes to a more abundant and reliable food supply. The economic benefits include improved livelihoods for farmers and greater food security. Automated harvesting is transforming modern agricultural practices. This technology enhances efficiency in food production systems. It ensures farmers can sustainably meet global food demands. Automated harvesting promises a more secure and productive future for agriculture.